Welcome to qnawire.
Alright, so first we're being asked to find the vertical and horizontal asymptote of f of x. So the vertical asymptote occurs when the bottom is equal to 0. So in this case, x squared plus 4 is equal to 0. However, if you attempt to solve this, you'll quickly realize that you'll get an imaginary answer. So there's actually no way the denominator can equal 0, so there is no vertical asymptote. So no vertical asymptote. To find the horizontal asymptote, we take the limit of the function to infinity and negative infinity. So we'll just do, we can do infinity. And so x squared minus 4 over x squared plus 4. So there's a couple of ways you can do this. You can just look at the leading coefficient and realize that it's just a ratio of 1 to 1, so it'll be 1. Or if you want to be a bit more rigorous about it, you can actually pull out the factor of x squared. So I'm not going to write the limit. I'm just going to rewrite it. Actually, I'll write it. It's a better idea. So I can show you that I'm actually applying limit laws. So I'll pull out x squared. So this will be 1 minus 4 over x squared. And this will be all over x squared. And I'll do 1 plus 4 over x squared. And then what will happen is I'll cancel these x squares. And if you actually apply the if you apply it to infinity, you'll realize that this function will go to 1 minus 4 over infinity, which is 0. And then 4 over infinity, again, 1 plus 0. And that gives you 1 over 1, which is just 1. And if you do it to negative infinity, it doesn't make any difference because it's squared. So you can also do plus or minus infinity. It'll still give you 1. So we have a horizontal asymptote at y equals 1. So horizontal asymptote at y equals 1. And that's all we have for asymptotes. So to find where the function is increasing or decreasing, we have to apply the first derivative test. So we'll do f prime of x. And this is a quotient rule problem, so you'll have to apply the quotient rule. So your final product should be 16x over x squared plus 4, and then you square the whole thing. So this equals 0. 16x equals 0, only x can equal 0. And there is no undefined number for this because it's squared on the bottom, so we don't have to worry about that for our interval evaluation. So now we create a sign chart, and we look at around 0 for the sign of f prime. So if it's less than 0, you get values that are negative. You get values that are greater than 0, you get positive numbers. And this tells us that it is decreasing from negative infinity to 0, and it's increasing from 0 to infinity. And there is also a local min occurring because it is decreasing and then increasing, so it looks like this. So there is a local min at x equals to 0. Now, we are going to look at the concavity of this function. So look at the second derivative test. So we take the second derivative. So again, we'll apply the quotient rule. It's a bit messy, but it should come out to be 64 minus 48x squared all over x squared plus 4, and then this is cubed. He said this equal to 0, so you do 64 minus 8x 48 squared. 48x squared equals 0. So you do 48x squared equals 0. So then you'll get x squared is equal to 64 over 48, and that's the same thing as 4/3. So then this will give us x is equal, so you take the square root, so you get plus or minus 2 over root 3 because the square root of 4 is 2. Now we're going to evaluate it around those two numbers. So the sign chart. So this will be negative 2 over root 3, and this will be positive 2 over root 3. And then now you're going to look at the sign of f double prime. So if you plug in values less than negative 2 over root 3, you get negative numbers. Between these two, you get positive, and greater than, you get negative. So this is concave down, up, down. So you have concave down occurring from negative infinity to negative 2 over root 3, and from 2 over root 3 to infinity. And you have concave up occurring between negative 2 over root 3 to positive 2 over root 3. Your inflection point occurs when the sign changes, so you have inflection points at both negative 2 plus or minus 2 over 3, so you have plus or minus 2 over root 3. Now you have enough information to draw the graph, so let's go ahead and draw the graph. So we have a horizontal asymptote at y equals 1, so I'm going to go ahead and draw this red line. So reminder that it is decreasing till 0, and it is concave down, so it's going to be kind of going down like this. So it's come down, and then we have a local min, and then it starts increasing at 0. So it goes up, and we have a slight U right here, and then it's going to go back to being so it's going to be concave down, and then concave up, and then back to be concave down. So it's going to look like this. And that is the graph of f of x. I believe it's f of x. Yes, it's f of x. All right.